Why is water important to life? Today we're focusing on the question written at the bottom of the screen. Can too much of the solute be dissolved in the water? Well, if you're the fish on the left-hand side picture, I think he's going to say yes, too much of something was dissolved in that water. And if you live in the city on the right-hand side of the picture, I'm thinking you're going to say yes, too much of something was dissolved in that water. So how do we measure too much? What does that mean? We're going to read a solubility graph to help us out. Just like any graph, before you try and use it, you look at the axes. On the vertical y-axis, you see solubility. This is the amount of solute that goes into our solution, and our solution in this case is 100 centimeters of water. So if I was going to have 200 centimeters of water, my numbers would all double. On the x-axis is temperature, and it's in Celsius. So what this graph is measuring is how much solute can dissolve at a specific temperature. And if you look at the lines, I have 3 different chemicals graphed on this sheet. 3 different vocab words today: saturated, unsaturated, and oversaturated solutions. A saturated solution holds the maximum amount of solute at that temperature. In this case, you have to be on the line. So for instance, if I look at 45 degrees and I go up here to the potassium nitrate line, that spot right there, that means if I go across, 71 grams of potassium nitrate can dissolve in a solution at 45 degrees. That's how I read that one. That would be a saturated solution. The solution can't hold any more. An unsaturated solution would be not holding maximum amount. So any point under the line would be considered an unsaturated solution. An oversaturated solution is unique. What happens here is we're holding the maximum amount, but undissolved material is still in the beaker. In other words, somebody put too much in, the water couldn't dissolve at all, so we're holding all we can, but there's extra laying on the bottom. This would be over the line. Over the line. So if at 45 degrees I would put in 100 grams of potassium nitrate, the solution would not be able to hold it all. The solution would only hold about 70 grams, and the other 30 grams, this difference right here, is undissolved. Undissolved, sitting on the bottom of my container. That difference there. So that's how we read a solubility graph. How do we measure solution concentration? 4 different mathematical equations. We can measure solution concentration using molarity, where molarity is symbolized by a capital M. That capital M is equal to moles of solute divided by liters of solution. And of course, liters is volume. Must be in liters. So we have that mathematical problem to do. We may need to change grams into moles using the molar mass. Percent mass percent is another method of measuring solution concentration. Mass percent is equal to the mass of the solute divided by the total mass of solution timesing it by 100 to give me a percentage. Parts per million is another method that you may have heard of to measure concentration. That is simply the mass of the solute divided by total mass of solution times 1 times 10 to the 6th, which happens to be a million. Notice these two equations are exactly alike, except for this one is times 100 and this one is times a million. Parts per 100, parts per million, so guess what parts per billion is? Same equation, mass of solute divided by total mass of solution, but we are going to multiply it by a billion, which is 10 to the 9th. So there are three methods on the right-hand side, all similar. We're just doing it parts per 100, parts per million, parts per billion of how much solute is in our solution. On the left-hand side, it is molarity, how much solute is in our solution. Your assignment, again, a 3-segment hybrid. Station 1. You'll be looking at solubility graphs. You'll read those at various temperatures, get some vocabulary words in there. Station number 2. Going to understand the creation of caverns. How do underground caverns and caves get created based upon the solubility of water? And then you're going to continue to work on your vocabulary logs. And station 3 is our lab station. I take that back. It's not a lab station. It's a math station to perform calculations to determine concentrations. So you're using those 4 math formulas that I showed you on the previous slide. So you'll want that slide with you when you go to that station. Enjoy and go learn.